Ted, and it's a pleasure to be here today to talk to you about the impact of early life factors on the developing gut microbiota and the stress response, which was part of the responsibility of University College Cork to undertake as part of the MyNewGut programme. And I'd like to acknowledge and thank Yolanda Sands for her wonderful coordination of the MyNewGut programme, and it was a pleasure to work with you, and hopefully we'll be able to continue working somehow in the future as well. So in my talk, the objective of the study that we conducted was to look at early life factors, in particular antibiotic exposure, and as a result the altered microbiome in early life and how it impacted on neurodevelopment and the stress response. So it's well established that the first 1,000 days are particularly important for the developing infant in terms of early microbiome development, the immune response, and of course the importance of nutrition and early life factors in this regard. And indeed it's been well established that certain early life factors such as mode of delivery and early infant nutrition are important in terms of gut development and neurodevelopment as well. So in the work that we conducted, I want to introduce cohorts of infants that were recruited in order to address the question as to the impact of early life exposures on gut microbiome evolution. So I'm going to talk today about the MyNewGut cohort and INFANTMET cohorts that were used. So starting with the INFANTMET cohort, these are infants that were recruited in Cork, and we recruited 50 infants per group, 50 which were standard vaginally delivered, compared with C-section delivered full-term babies. There was a preterm group of babies as well. And then in the MyNewGut study, we aimed to recruit infants that had an altered microbiome while they were otherwise healthy. So these were full-term babies that were C-section born, but for whatever reason were exposed to antibiotics in the first 4 days of life. These infants were recruited from 2012 to, in fact, ongoing. So the study's not quite over yet. So we recruited the infants and sampled stool samples at week 1, 4, 8, 24, years 1, 2, and year 4 of life. And also other biological fluids were taken, such as urine and saliva, and various health questionnaires were administered throughout the study as well. And so what I'm going to focus on today is to present the data that we have on the microbiome evolution over the first 4 years as a result of the different early life exposures. So first of all, to look at the INFANTMET data set to week 24, shown on this slide is the microbiome composition as a result of C-section versus a standard vaginally delivered birth mode, and the preterm infants are shown there as well. So this is the data at phylum level up to week 24. So on the left, I guess I said I wasn't going to use the pointer, but just on the left column is shown the microbiota of the full-term C-section born babies, which I'd like you to compare with the full-term standard vaginally delivered born babies. And so I suppose the thing to note there is the flux that occurs in the C-section born babies microbiota compared with the standard vaginally delivered microbiota, which is already pretty stable even 1 week after birth. So the blue bar there shows the actinobacteria, which is already well established in the standard vaginally delivered babies and represents up to 50% of the microbiome composition at week 1 and is stable throughout the 24 weeks studied. On the other hand, the C-section microbiota is in a state of flux following birth in the first weeks of life, and is initially down at 20% of the microbiome, but stabilizes and increases to about close to 50% by week 4 and up to week 8 of life, and then stays stable further on. we're not really focusing on preterm microbiota, but you can see there that it was further modified as a result of preterm delivery, and also, of course, in parallel, there was quite a significant antibiotic exposure to the preterm born babies. So these infants have now been followed up to 4 years of age, and we looked at microbiome at years 1, 2 and 4. And what we found was that the microbiome composition continued to evolve over the up to year 4, with a continued decrease in bifidobacteria relative abundance, and increase in Christiansonella and Ruminococcaceae. Looking at the diversity of the microbiota over time from birth, we found that there was a significant increase in diversity of the microbiota of all groups from birth to 24 weeks of age, by which time diversity had stabilized to a large degree. And there were differences in terms of the early microbiome diversity as a result of birth mode, with the standard vaginally born babies having the highest diversity in the early days and weeks after birth. Looking at diversity up to 4 years, we found that there was a continued increase in diversity from years 1 to 4, and also we found an impact of gestational age at birth on the microbiome diversity up to 4 years of age, so much so that the very preterm born babies still had lowest microbiome diversity at 4 years of age. Looking at the clustering of the microbiome, we found that microbiota still clustered as a result of a year of analysis. So in other words, the 4-year microbiota data set clustered away from the 1-year data set, with the year 2 data set kind of in the middle of the years 1 and 4. So that's the data that I have on the INFANTMET cohort. So now I want to move on to the MyNewGut babies. And again, remember that these were the babies that were born by C-section delivery, which I've already shown you has a significant impact on microbiome composition in early life. But now these infants, this is a new group of infants that were also administered antibiotics in the first 4 days of life. And we compared the microbiome of these infants then with the previously shown INFANTMET cohort. So recruitment of the MyNewGut infants involved recruitment of 50 subjects, which have been recruited, and indeed the analysis of the samples is ongoing, because recruitment has been completed of all babies, but they haven't been sampled out to 2 years of age yet. That's ongoing. So what I want to show you today is data from weeks 1 to 24 of 30 MyNewGut infants compared with INFANTMET controls. And then we conducted Bailey's assessment on those infants that already have reached year 2, and I'll have some data on that as well. So looking first at the infant gut microbiota, we found that there was an alteration of microbiome composition over the first 24 weeks at phylum level. And indeed, what we found there was that there was a significant impact of antibiotic exposure to the C-section born babies in terms of the bacteroides were significantly impacted at week 1, and there were also differences seen in some at the phylum level at week 24. At the genus level, we found several differences in microbiota, which are shown are shown here, and are actually the significant alterations are shown here in terms of the several genera that were found to be still significantly different in the MyNewGut babies at week 24 compared to the C-section born INFANTMET babies. Yeah. So in other words, the the impact of early life antibiotic exposure was still apparent in gut microbiome composition by week 24 of life. As we conducted Bailey's assessment of the infants at 2 years of age, and the Bailey's assessment is a series of tests that analyses cognitive, language and motor skills of the infant at 2 years of age, and some of these data are clinician rated and others are parental reports. So this is a composite score. So overall, our data indicated that there were no significant difference in Bailey's scores as a result of early life antibiotic exposure of the C-section born infants compared with the INFANTMET controls. So to conclude, we found that perinatal factors, gestational age at birth and delivery mode continue to impact gut microbiota to 4 years of age. And we did find discriminative taxa at different time points over the first 4 years, including E. coli, Shigella and Bifidobacterium, which were most prevalent at year 1, Lachnospiraceae at year 2 and Christianella were emerging by year 4. We found that antibiotic treatment after C-section birth mode impacts microbiota composition to 24 years. But however, that altered microbiota does not impact motor, language and cognitive development at year 2. And that concludes my talk, and I'd like to thank the MyNewGut team based in Cork, led by Ted Dinan, who of course is here, and particular thanks to the clinicians Tony Ryan and Jean Dempsey, who were responsible for all the recruitment of the INFANTMET and MyNewGut babies, and all the researchers who did all the work that I talked about today. Thank you very much for your attention.
Thank you very much, Catherine. We have an opportunity for 1 or 2 short questions, please.
Thank you. My name's Adam Balin. I'm a gynecologist from Leeds. I'm a fertility specialist. It's about 25 years since I did any obstetrics, but I'm obviously aware that people or women need caesarean sections for different reasons. And so one of my questions is, were the caesarean sections elective caesarean sections, or had the women's waters already broken? Were they in labour? Because that would presumably make a difference. Mm-hmm. And second question is whether you looked at breastfeeding and whether that has a difference, which I would suspect it may do.
Okay, thank you. Were the babies born by elective or emergency C-section? It was a mixture of both. And yes, you're absolutely right that, of course, that could have an impact, the elective versus emergency. In terms of practice in Cork, whether it's elective or emergency C-section, the women all get antibiotics at the time of incision. So there's no difference there in terms of antibiotic administration as a result of elective versus emergency C-section. So I think that answers that question as best I can. Your second question was in relation to breastfeeding. All the INFANTMET babies were breastfed for the first 4 weeks of life. Okay, that was an inclusion criteria. That wasn't the case in the MyNewGut because it was just so difficult to recruit babies that were full-term, healthy, but yet got antibiotics, so we took everyone we could. So there was a mixture of formula feeding and breastfeeding and mixed feeding in that group. In the INFANTMET study, to 24 weeks, we did look at duration of breastfeeding and its impact on microbiome composition. And we found that breastfeeding had a more significant impact on gut microbiota of the infants born by C-section than standard vaginally delivered birth mode. In other words, potentially telling us that breastfeeding might be more important to mature the early microbiome in the C-section born infant, indeed, compared with the vaginally born infant.
One final question, please.
Milka Sokolovic from UFIC. There seems to be an association between in vitro conceived babies and gut health and gut maturity in the first years of life. I wonder if you have had any in vitro conceived babies in your MyNewGut cohort, and whether it has shed any light on this, and otherwise whether you are aware of, or whether there is any microbiome explanation to that association.
Actually, I don't think we know whether whether the babies were born via in vitro fertilization in the MyNewGut and INFANTMET cohorts. We recruited the babies at the time, well, you know, at the time of birth. So it wasn't a question that we asked as to how they were conceived. And so, yeah, I don't have any data on that, unfortunately.
Thank you very much, Catherine. Thank you.